Hi, Åke Hedman from the Paradise of the Frog, or Grodans Paradise. I want to show you the old bootloader interface that is available and has been available for VSCP for I think it's 10 years or something. But after the rewrite of the communication engine, it's in place again, and it's been broken for a year or so. Um, the special thing with the VSCP bootloader interface is that it's a uniform bootloader interface. It works on Ethernet, it works on TCP/IP, RS-232, CAN, etc., etc., and it will update your refrigerator, your car, your sound device, or your relay unit in the same way and with the same interfaces. What we will look at today is a developer tool. For an end user, it should look much nicer, of course, and be on a phone or something, or on a tablet. But in this case, we have a PC application, VSCP Works, which is a developer application, and it doesn't have to look nice. It's for developers. What this bootloader does is it first asks the actual device what bootloader it uses, and then it uses that bootloader, and then it looks for what files are available to update on this unit. So the user doesn't need any instruction manuals or things like that. He or she just starts the updating application, can be told by the device that it's needed also, and then the process is automatic or semi-automatic. So what I have here is one unit on my desk and one unit in New York, and we can check what I have here first with the scan. Um, See this. I scan everything that is here, and we see I have two units. I can read the MDFs of these units, and we see this is a Paris unit, which is something the Paradise of the Frog makes and sells. It's a relay module, and I can check what this is also, and we see this is an Kelvin NTC 10Ka, a temperature sensor module. But what we will update today is the Paris module we see here. So, and this one, and we go to the bootloader wizard. I have a pretty slow machine here because I have the development environment and very little memory. After all, I'm an open source developer, and we don't have a lot of money to buy memory for. So this is the VSCP bootloader wizard. We select the interface where the device is located, and this can be, as this interface we have here selected up here, a local interface where which is connected directly to my computer, or it can be a remote location as it is here, so we can update the device that is located in New York or on the moon or on Mars or somewhere else in the solar system. So but in this case I select the local interface, and here it is, and we go to the next, and the IDs of the devices filled in, and in this case we saw the ID was 1, and we continue. And what's happening here now is that the bootloader wizard goes out to the device and asks what bootloader algorithm it uses, and sets it here. And as you see, this is a Microsoft PIC algorithm. you have for Atmel, you have for ARM processors, and you have a general VSCP algorithm, which is the most powerful. And you can use a lot of them, and this is possible to extend also, so you have a modular system. But we want to use this one here, so we press next. And what I can do now is load the available files from the MDF, but as I'm sitting and developing this now, I load a local file instead. And this is the latest code for the Paris module, and I load it, and I get some info here, what it contains. It could be flash memory as it is here, and it could be some config memory programming, nothing in this one, and it can be some EEPROM code. It depends on what you have. So I can go back here for example and show the other algorithm. There you have the VSP standard algorithm also. We go back there. So now I have the code loaded also, so I continue, and we're ready for the bootloader process. And I click here and start it. What this does now is first it start the bootloader in the device, and then it starts to load the code, and that's what's happening now. And at the end here it will restart the device and then check if it's up in normal communication mode, and it is. If we didn't get any error messages here, everything is okay. The module is located in New York or on the moon or on Mars, then we use the TCP/IP interface, and we actually connect to a remote daemon and use an interface on that daemon where the module is located. So in this case we use this machine which have a socket CAN interface, and we can scan this too. It's a bit slower, of course, because we have the overhead of TCP/IP. And let's see if it finds any modules over there. Two modules found, and I know this is a Paris module again, so we go to that one, and it was this interface, and we move on. Okay, didn't find it first here, and as you see here is a different address for the module, or what we should call it. It's called a GUID in VSCP, Global Unique Identifier, and what you see in the first part here is the interface we are interested in, and the last part is the node ID on that interface. So together this forms the address for the node. This is actually not the real UID for this device. It's the interface and the node ID combined, and it's a sort of a proxy for the node. But we use this, and again the MDF is fetched from the node, and the bootloader firmware check the bootloader algorithm, and we already know it's the microchip pick algorithm on this device, and it's selected there. So continue. Again, I load the local file because I have the latest greatest software on my machine. I want some special thing here, and this is the same thing as the last run, and we continue, and we program the device, and again it's set in bootloader mode, and we stay in bootloader mode until it has some valid software, and then the software process starts. this will continue for a while, and after it's ready, it will check if the device is awake again, and yeah, if it doesn't wake up again, we can do this again. No need to sit and wait for this. It takes longer, of course, because we have the TCP/IP overhead and the server overhead, but it's secure. Every package sent is validated, and etc., etc. So it's very secure bootloading. Okay, that's it. Bootloading for the world, sort of.